We'd like to get started with tonight, the meetup. I'm Steve DeRico. I'm the organizer. I'm the founder of NS Meetup. We've been doing this for a little over 3 years now. Quick show of hands. Who's at their first NS Meetup? All right. Round of applause for the newbies here. Welcome. Yeah. If you guys haven't figured it out already, we typically meet on a Wednesday at the beginning of the month, talk about iOS, programming, open source. It's a great place if you have questions, you're trying to learn programming, or you've been around the block and maybe you want to help out some other people or share some knowledge. That's why I started the group. If you're interested in speaking, please come find me. I'm always looking for new speakers, and maybe if you don't want to speak but you want to hear about a particular topic, please let me know. If you're not interested in saying something in person, my email is all over the NSMeetup.com website, so you can reach out to me anyway. I'm also on Twitter at Steve DeRico, or the @NSMeetup handle works well. I appreciate you guys coming out. Just a couple of kind of house rules here. There's plenty of beer, snacks, drinks, all right there. Just please, the recycle's right next to it. If you're looking for the restroom, it's just through the doors, past the elevator, and on the right-hand side. One more. Oh, we're going to be here until about 9 o'clock tonight. So if you guys are going to be kind of hanging around a little bit longer, please help me out. We got to clean up, put away all the chairs. I'd appreciate your help if you're still around. With all that said, I'd like to introduce tonight's speaker, Peter Livesey.
Hi everyone, my name's Peter and I'm an engineer at LinkedIn. Today I want to talk to you about a new framework that we've open sourced to test view layout. First I'm going to talk about the current options that we have for testing iOS applications. Then I'm going to tell you why we wrote LayoutTest and run through an example of how you might write your own layout tests. So here are the current options for testing iOS apps as I see it. You can write unit tests, automation tests, or do manual testing. Of course, you can also just choose not to test a certain feature. For unit tests, the most common solution is XCTest, but there are a few other open source solutions such as Quick, Kiwi, and Spectra. A lot of these are built off the XCTest framework. Usually use some kind of helper library like OC mock or HTTP stubs, which just provide the mocking functionality needed for writing unit tests. Most unit tests follow the same basic pattern. You give a procedure some input and you validate that the output is correct. This works great for testing like business logic of the application and any code that you can like isolate really well. Unit tests aren't great at testing sort of like large piece flows and large UI code because it requires a lot of state and it can be less stable as you add other features. It works really well when you can isolate the code that you want to test. The second thing you can use is automation tests. There's the Apple provided solutions of UI automation and also the new UI testing framework. There's also a bunch of open source libraries for this, such as KIF, which is what we're using internally at LinkedIn. There are two types of automated tests. There are white box tests and black box tests. So white box tests generally run as part of the XCTest framework. They have full access to the running application. You can access all the code from the application. They generally run as part of XCTest. Often they're written in Objective-C or Swift, and you commit the code with the actual application. The other option is black box testing. These tend to run separately from the application process and access the application using accessibility identifiers, and they can manipulate views, do swipes, touch buttons, stuff like that. The advantage of them is they're often cross-platform. You can run the same tests on Android and iOS, and because of this, they're often written in a non-Apple language, such as JavaScript. Automation tests are really powerful, but they're notoriously difficult to write and maintain. False negatives are really common. Tests can be slow to run because you have to wait for the app to actually run animations, load screens, things like that. The last option is manual testing. So by this I mean, you install a build on a device, you have a real person sit down with some kind of script, run through, visually verify that certain things are working correctly. This is basically your typical QA team setup. This is the easiest to set up, but it doesn't really scale very well. Every time you need to validate a build, you need to have real people sit down and run through all these scripts. If the build fails validation and you have some bugs, you need to go back and fix those bugs and then maybe rerun all or part of these tests. If you want to test on different devices, this just multiplies the amount of work you need to do by 2, 3, 4x, or however many devices you need to test on. Given this, though, it is a well-known pattern, and there are a lot of people who run this and have general good patterns. It's really easy to bootstrap quickly. As you go down these options, the cost really goes up for these tests. You can say cost is like time or money or energy, but basically, as I see it, one of the main goals for testing is to try to test with things like higher up in this pyramid. So whenever I'm writing a new feature, I'll first try to do everything I can to solely test as much as I can with unit tests. If I can't test something because of the limitations of unit tests, I'm going to move further down this pyramid and try other options. But I really want to try to use stuff higher up in this pyramid. So let's look at LinkedIn about a year and a half ago. We were starting to write a flagship application from scratch. We're going to rewrite the whole code base. And I'd worked on the old application for about 2 years. At this time, we mostly used a combination of manual testing and black box UI testing. At the time, we used Appium, which is a JavaScript framework, and it runs separately from the application. First of all, our testing cycle was really expensive. It would take us about a week to validate builds. When we did find bugs, well, first of all, the bugs could be 2 to 3 weeks old, and it'd be really hard to find the actual commit which caused this bug, so it'd be slow to fix the bug. Once we fixed all the bugs, we'd have to rerun this whole suite, which would take more and more time. Testing on different devices was really tough. For the automation tests we had, they were really flaky and difficult to write. We had lots of false positives and tests that would fail. So often what we'd do is we'd run our suite and we'd get about 85% passing. And someone would look at it and say, oh, don't worry, those 15% that fail, they always fail, so it's okay, we can continue. And basically this just, reduced our confidence in our tests and really proved that we weren't getting a huge amount of value from them. Top of this, developers hated writing automation tests. No one wanted to code in JavaScript, and with all the problems we had, they didn't really feel great about doing it. I will say that since then, we've actually improved how we write automation tests a lot. We've moved to using KIF. We've done a lot of changes to KIF to make it more stable and run quicker. But regardless of this, I will say that it is difficult to make UI tests easy to write. Given all of this testing we were doing, we were still shipping the application with bugs. One of the common bugs that I saw was small UI bugs and layout bugs in the application. Although they didn't actually cause a feature to break, they would hide information and generally make the app look kind of crappy and not something we were super proud of. One of the most common scenarios this happened was when we switched languages. Most of the testing we did was in English, and I don't speak any German, but because of all this stuff, I learned that German is a very verbose language. So often when we switched to German, we'd see something like this. And in this case, the label is longer than we thought it would be and is extending past the view. And it just doesn't look great, not a good user experience, not something we want. So for our automation tests, even if it looked at this, usually what it does is just validate the presence of elements. So it'd say, yes, there is a label here. Yes, it does have the correct text, so this must be good. Let's go. But clearly, there's a bug. So we decided to write LayoutTest. One of the things that we realized is you can validate the layout of the view without even adding it to a window or rendering the view on a device. You can do most of it in code. This meant that we can write these layout tests as part of our unit test suite, which means they can run really quickly and be very stable. The general flow of the test is that you can take some data, bind it to a view, take this view, run an auto layout pass on it, and then validate that all the CG recs and stuff are in the correct place. In this way, a single test can run on multiple different combinations of data, and we can reuse the test again and again. So, where does this fit into our testing pyramid? Well, I think it sort of sits between unit tests and automation tests. Unit tests are still the easiest to write. You can write them in a single line of code. Everyone's written unit tests, they understand them, they know how to read them and such. But layout tests do something which is traditionally difficult to do with unit tests, and that's to test actual UI. Layout tests are still much, much easier to write than automation tests. First of all, they don't use as much state because they don't actually run the application. They don't require the whole application to be running. This makes them much more stable. We have about over 100 layout tests right now in our application, and they test about 30,000 views. Every single time we commit, we run these tests, and as far as I can remember, we don't really have any sort of serious problems of them failing unexpectedly. Also, these combined with all of our other unit tests run in less than a minute, so they run pretty quickly. Okay, so let's take a look at what it takes to write a layout test and what a layout test actually does. For this example, we're going to test this view. This is taken from our sample application, so you can go check out the code on GitHub and run the test yourself later. There's three main elements. On the left, there's an image view. If the data says there should be no image, then it will take that out and the text will be sort of left aligned with the cell. There's a label in the middle which sort of expands the cell as text gets longer. And on the right, there's a button which again is optional and might be missing. There are three main steps to writing a layout test. First, you write the data spec. Then you write a function to bind this data to the view. And the third thing is you actually write the test itself. For all these examples, I'm going to show the code in Swift, but the library works great with Objective-C too. So the first step is writing the data spec. Generally, we write these as an extension on the view we're actually trying to test. We can commit this extension to the testing target, so none of this code needs to actually affect your real application. So the job of this basically is to provide the data which you lay out the view with. The one main difference is instead of concrete values, we're going to use data values subclasses. So for instance, instead of providing a real concrete string for text, we're going to provide this LYT string values instance. Instead of for the button enabled, we're going to use LYT bool values. And for image type, we're going to use a custom set of data values, which we think would be good for testing image type. Basically, what the framework will do is it will take this data spec and replace these with real strings and ints and bools and things like that. By using this, it can generate a bunch of different combinations of the data. So it can test a bunch of edge cases. It can test sort of a normal length string, an empty string, a really long string, null, can test negative numbers, positive numbers, 0, stuff like that. This isn't actually how the code of the framework looks, but it sort of serves as a good example of what's going on. Basically, you can think of it as a bunch of nested for loops. So it's like for every possible text in the spec. Text property, for all the button text, for all the button enabled, for all the image type. We'll use these values to create a dictionary. Given this, you can see that this is going to produce an exponential number of concrete data objects from a given spec. This is actually usually a good thing, because with very little work, you can actually get a lot of test coverage, which is going to test a lot of edge cases, which you may not have thought of when you wrote the view. However, it is exponential, and sometimes data specs can get really long and complex, which can cause just way too many of these to be created. There is a really easy sort of property you can set to say, hey, I have a complex data spec, please give me a linear number of data objects instead of an exponential number. We haven't needed to do this much. We just have a couple of tests which use complex data specs, but it's an option, so you can definitely use it. Yeah, go ahead, I suppose, if there's a question.
Yeah, just a quick question. Is there a way to make a bounds to keep the state space from exploding on the input? So in other words, the bounds on, for example, text could be, a maximum of 8 characters wide, right? That kind of
Yes, there is actually. The data, these values, these initializers. Oh, sorry. The question was, is there a way to set bounds on these to limit this to be a max of 8 characters? There's an optional parameter here to pass in a filter closure. And so you can say like filter closure, return $0.count less than 8 or something. Yeah. So step 2 is implementing view binding. So this is normally a really easy method to write. Basically what you're just going to do is create a instance of your view, however you do it, if you load it from a nib or anywhere else. Call setup with data and basically bind the data to your view, and then just return the view. This data object here is not going to contain any of those data value subclasses. It's going to contain real strings and ints. So this method's actually going to get called multiple times per test, as it basically once for each combination of data. The last thing we need to do is write the actual layout test. So first we subclass layout test case, and then we write a test and call run layout tests. Swift's going to use type inference to know that we're going to test a sample table view cell here. And then we have this closure. I'm actually going to leave this blank for now, because even without writing any additional code, we're going to still get some value from this test. Because there's a bunch of automatic tests that layout test is going to run on all of your views. So first, it's going to make sure that no views are overlapping. It's also going to make sure that all views are contained within their superviews. It makes sure that there are no auto layout errors. These are the errors you see sort of printed out for the console when you have like impossible constraints. Make sure there's no ambiguous layout. And then also does some basic accessibility checks. I actually really like this last one because adding accessibility to applications is pretty easy, but I feel like most people don't do it because they either forget to do it or like a bit lazy. So what this does is it makes sure that all the UI controls in the view should have an accessibility label, so accessibility users can access them. It also makes sure that no accessibility elements are nested, because otherwise we're hidden, again, from accessibility users, and that anything with an accessibility ID also has an accessibility label. So basically this is, if nothing else, a quick reminder to you to say like, hey, remember about accessibility. If you add a new view and you don't do any of this, the test will fail, and say, hey, go back, think about your view. How is an accessibility user actually going to use this view? So these are basic rules that we feel that most views should adhere to. But of course there are exceptions. For instance, you might have a cell which has a background image view, which stretches the whole width and height of the cell. Obviously, this is going to overlap with every other view in the cell, but this is by design. So it's really easy on these tests to say like, hey, framework, ignore my background image view, and it will check to make sure everything else isn't overlapping. But if anything overlaps with the background image view, it won't fail the test. All these rules are also configurable on a per test or a global basis, so you can make sure you're testing exactly what you want to test. Finally, we can add our own custom assertions about the view that we want to test. So for instance, you can make sure views are aligned correctly and that they're laid out in the correct order. Here we're going to make sure that the title label and the image view are top aligned. The library ships with a bunch of helpers to make sure that sort of this is laid out before this view or on top of this view and things like that. It also has, built-in support for like Arabic and making sure that, before might mean something different in right to left languages and things like that. The next thing you could do is verify that the data was bound correctly to the view. So here it's just making sure that the title label text is actually correct. You can go through and make sure all the other data is correctly bound. And the last thing is that whenever we write views, like often we add sort of like mini features. So we might add some feature where if a button is disabled, it should be hidden or squashed or something like that. Here's where we can add code to validate this feature. Often with auto layout, when you need to add some new feature or change something around, the easiest thing to do is just like delete all the constraints and just redo it all. And when someone else does this to your code, they might forget to add the feature which you've previously added. So basically, this is where you can validate that it's going to, in the future, it's always going to be there and your feature is going to be working correctly. As a reminder, this block's going to get run multiple times. So once for every data combination, every view, it's going to run this again and again. So this style of testing is actually nothing new. It's commonly called property-based testing, and it's really popular in functional languages. So the idea of taking a bunch of different inputs and feeding it to one function and then validating the output in a consistent way. It's really good for view testing because even with very different input, the output looks very similar. Like the view always looks pretty much the same. So actually, in practice, when writing these tests, you don't actually need to do that many if-elses based on your data spec or if this is there, that kind of thing. Most of the tests that we run are, like, apply to every single view. There is one main difference between layout test and these property-based tests, and that is that property-based tests often have random input. So if you're giving it string input, it will pick random strings to feed it. So every time you run the test suite, it's going to give it different input. The idea of this is it gives you like more test coverage over time. We decided against this for layout test because we figured that with a static set of strings and integers, we would get a lot of test coverage and enough test coverage. And we really made it a priority that these tests should be really stable, very debuggable, run the same way every time. So what happens if something goes wrong? Basically, the test would be pretty useless if they never failed. So it's important that when something fails, we're quick to fix the bug and keep coding. So whenever a test fails, it takes a screenshot of the failing view. It saves this to disk so you can view it later. At the end of the test suite, it's going to generate an HTML report of everything that's failed. It's going to give you a description of the failure, an image of the failing view, and then the data which caused this failure to happen. Given this, it's pretty easy to sort of debug what went wrong. Here it's clear that these things are overlapping and they shouldn't be. Since we're already running all these tests multiple times, it'd be nice to handle different device sizes. Apple, every couple of years, releases a new couple of different device sizes. Fragmentation right now is like worse than it ever has been. It's also really expensive to test this normally. If you're doing manual testing, you need to go buy all these different devices and test them on all the devices, which can take a lot of time. So the framework has built-in support for this. You can provide globally or on a per test basis a list of view sizes that you want to test your views on. As it runs the test, if you specify 3 view sizes, it's going to run 3 times as many tests on these different sizes. The main idea with this is that these tests are going to run really fast, and hopefully with this, it should help you reduce your reliance on automation tests and manual testing. So at the very least, you'll have a bit of confidence that your views are laid out correctly on all these different device sizes. So you might be more comfortable not testing every single device type, for instance. There are a few additional features. I'm not going to go into a lot of detail, but you can test reuse of cells. So instead of creating a new instance of the cell for every iteration of the test, you can create one at the start and you can reuse the same cell every time. This is good because this is what happens in table views and collection views. So you're testing this flow of finding new data to a cell which has old data bound to it. Another feature is the catalog, which you can see here. Basically what this does is it runs through all the different combinations of data and shoves the whole thing into a table view. This is good if you want to see what tests are running. You can also run this and sit down with your designer and say like, hey, you gave me this one spec for this view, but it turns out this view can be laid out a bunch of different ways. There's some edge cases that we didn't think of. What do you think of this? How do you think this should be laid out? And finally, it gives you the ability to test view controllers too. strictly you're only going to test the actual views of the view controllers, but sometimes you have views which can't actually be laid out by themselves, but require something from viewDidLoad or something to actually do the layout of the view. The framework basically allows you to have additional objects which are required to lay out the view, and it keeps them in memory until the test is finished. So it can be a view controller, it can be some kind of a view layout object. There are some drawbacks to the library. The main one is that you can't test actual UI flows with it. It only validates the actual view. And as I said earlier, it doesn't actually add the view to the view hierarchy. It doesn't add it to the window. It doesn't require an application to be running. So you can't like tap on buttons and push view controllers and stuff like that. It's really concentrated on the view itself. This is by design because we want the test to be really fast and stable. And anytime you add that extra state, you're going to be introducing possibilities where the tests can fail unexpectedly. The tests end up looking a lot like unit tests in the end, so anything you can do with a unit test, you can do with a layout test. It just adds this extra functionality on top to help you test your UI. I'm going to finish with like sort of a word of caution, I suppose. Testing is an art, not a science. It's really easy to get into holy wars with people about like which testing strategy is going to fix everything and it's the new thing and it's going to fix all of our problems. But usually the solution isn't nearly as polarizing as people make it out to be. We usually don't have much time to test applications, or at least we don't have enough time. There are very few developers who say that they have no product deadlines and they have plenty of time to write all the tests that they want and they're super happy with it. So really we've got to use that time efficiently. All of the options that I talked about today are just tools for you to use. Basically, no one tool is going to solve all your problems, but we've got to be creative and use them in the right capacities and in the right circumstances to help get great test coverage. Hopefully, LayoutTest is going to be a good option. Hopefully, it should help us move further up that pyramid, reduce our reliance on automation tests and manual testing. And everything is open source. Everything's up on GitHub, so excited to hear what you guys think about it. And that's everything I got, so thank you. So I think we have plenty of time for questions, so if you have any questions, yeah, go for it.
Would you say that that style of testing layouts kind of encouraged you guys to extract data from the views and have it more, like a pure function kind of thing, right? Where just give it some data, it renders, doesn't have any other behavior, or it's, that didn't help with that.
Yeah,
I'm thinking
go ahead.
that would tilt you or shift you towards doing like React style components, if you will, but just with native code, right? Just a pure thing, you give it some values, it renders itself, right?
Yeah, so the question is if you write tests this way, does it like promote writing views in a way such that you just sort of give it data and it renders with sort of no side effects, a more functional way, also like with using React or something like that. So yeah, I definitely do think that. We don't really use React at LinkedIn, but no, I think that, I mean, maybe it is a requirement for this, because basically unit tests are always best if you write functional code. It's much easier to test if it doesn't have side effects. And so again, it's like, well, hey, laying out our view should be functional. We should just give it data and it should lay itself out and that's it, and it shouldn't touch anything else. So if you write your views that way, I think that this encourages it. So yeah, I think so. Go for it.
How do you deal with, this is sort of on the same topic, but how do you deal with things like asynchronous image loading where you can't necessarily treat it that way, but...
So the question was, how do you deal with asynchronous image loading and other asynchronous tasks? So there are a couple of different options. One which we use for this is just mocking it out. So we have an async image view class. For us personally, a good part of it is written in Objective-C. So we just use OCMock and we just like switch that out so it's a synchronous function. And we load a certain URL, we show a certain stock image, and then at the end we actually write a helper function which says, please verify this image and this URL, and it checks image equality, that kind of thing. So I think, yeah, mocking is one solution. If mocking really isn't a solution, for instance, you might be using some asynchronous layout engine. I suppose the only solution right now is just to put a weight into your test. It should be pretty quick. I suppose that might cause some performance issues if you're having such complex layout that it's actually really slow. But yeah, I think just you can always put a weight in your test and wait for it to finish. Yeah, go for it.
How do you handle different orientations or the possibility of an orientation change mid-test?
Yeah, so question was, how do you handle different orientations and orientation change? This has come up before. I think one thing which helps is if you use the reuse cell function, because if you only ever use one view for your test, then what will happen is when you run it on a different size, it will just like stretch this view to that size and expect the layout to work. So I think that gets you part of the way there. In terms of actually like, maybe you're running some kind of animation in your view controller when you like rotate it such that the cell does something nice. I think that kind of like reaches outside the scope of this, because that's when you're really talking about like, it's kind of a flow. You're like, shifting the view controller in some way, some like real UI kit codes being fired and stuff like that. So I don't think it goes quite that far, but I think that knowing that a view can be kind of like, as these tests run, basically it's going to take the edge of the view and just like stretch it to all these different sizes. It gives you a bit of confidence, I think. Yeah, go for it.
Adding on to that, also with the different sizing options, you can have the sizes it runs through the iPhone 6 portrait and iPhone 6 landscape or something like that. So
right. So yeah, the common way that the sizing options works is that you basically can specify a width or height or both, but normally you actually only want to supply a width, or that's the most common thing for cells, because it's really the width which is being stretched, and then the height will adjust based on the data inside of it. So yeah, you could basically, as Kyle said, you can specify like an iPhone 6 width and an iPhone 6 height as the width, because that's landscape. Yeah, go for it.
Do you find that with this testing framework that you tend to write the test before you write the production code, or the other way around?
So the question was, do you write the test before or after the production code? I think normally we still write the production code first. I think that I actually, in terms of like that as a tool, like test-driven development, all that kind of stuff. Yeah, I think it's a great option. I don't think that a lot of people at LinkedIn are practicing it normally. I think also views, it's still kind of like, you still kind of want to see it running. You want to see it like on the screen. I don't know, it's just kind of a thing when you're writing views. You certainly could write the code beforehand. I suppose to write the test, you just need to add all the IB outlets or all the hooks so you can do that and validate your view. I suppose like introducing the test at least earlier in the cycle so you can start getting stuff like, oh, you've done everything except accessibility, you've done everything except this, that kind of thing might help.
But somewhat associated that, I mean, you have a view hierarchy. Where in that view hierarchy do you say, let's write a test for this view? And then, you could go full on and say, write a test for every view, however deep you are in the view hierarchy.
Mm-hmm.
But, I mean, I would imagine that you pick a level and you say, this is where we go. How do you determine that?
Yeah, so the question is, how do you decide where in the view hierarchy to decide to write your layout test? I think for us, it's been a really easy decision because most of the stuff we're testing is collection views and table views, and like just testing the cell is like a really good place to do that. I suppose it kind of maybe just depends on the complexity of the data specs and like where you write the views. Maybe, if I write a custom widget, like I write like a custom LinkedIn button, which has like 2 images and text or something crazy like that, it might make sense to write a layout test for that, as well as writing a layout test for something which uses this button. I suppose in general, I don't feel like we have a lot of custom nested views. Like most of the view hierarchy is one custom view and then a bunch of Apple components, and maybe a couple of like our own async image views in there and things like that. So think it ends up being relatively easy in practice, I suppose. I don't have a fantastic answer, I suppose. Yeah, go for it.
So last year, I think it was F8 conference, Facebook talked about how they have a ton of tests. And what they do with it is they actually block commits from merging forward to release. But in order to prevent bad tests, false positives from preventing that, they have a probationary collection of tests. Have you been able to like set that up? I've been trying to like figure out how I would do that with tests, maybe a different test target associated with different tests.
Right. So the question was that Facebook has blocks failing tests for commits merging in. They have this probation period if you have these flaky tests which fail. I don't know. I suppose maybe we should talk about this more afterwards so I can give a quick answer because we've done a lot of work on this. We've taken a bit more of an aggressive stance on this actually, in that we commit our code and we run all of the tests with just your commit. Only if all of the tests pass does your commit gets merged into master. Then we run your tests again because there might be additional commits, and it goes back and forth. Sometimes we revert that commit, sometimes we don't, depending on the week. But we do. I suppose we do a bunch of stuff for that. We don't do probation periods, so it makes it easier engineering wise. First of all, our unit tests can run as one target. Said it runs in a minute. For our automation tests, I think end to end our automation tests probably take an hour or two, but we have like around 10 different targets, each of which takes about 10 minutes, and we run them all on separate machines so that our automation tests can like finish in a reasonable amount of time, and then they all go back to the same machine, report the failures, stuff like that. I suppose like given that answer, that's why I'm sort of really like always pushing towards like automation tests are great, but like you start hitting these hurdles of needing to use multiple continuous integration machines to run them in a reasonable amount of time. To answer the actual question, our policy is basically if anything fails, blow it up, cause pain for the developer, then the developer needs to go work out what actually went wrong and fix it, and hopefully it'll be fixed going forward. Which we've had some success with and some frustrated people with, so. Someone has a question for his?
Actually. One, thanks also for this presentation. It's quite great, actually. The question I have is, in terms of like development time that you take to write the tests, sort of, if you were to split it between actual sort of writing the functionality and then writing the test, what would you the split?
I honestly don't have a fantastic answer to that, because I suppose, to be honest, I haven't written a huge number of layout tests, because mostly I've worked on the infrastructure side. Kyle, do you have any good, quick answer? Kyle also works at LinkedIn.
I can say the layout tests are probably the quickest thing to write, much faster than even the unit tests, since you kind of just set up this data, and then the checks you do are pretty minimal, just checking, if the one thing is to the left of another, so it's just really a couple lines. When you throw in actual unit tests and automation tests, then it's a pretty good portion. Again, I probably don't have a good answer on exactly how long, but definitely the layout test is the smallest amount of effort I've seen, and actually has caught a lot of bugs for me personally.
So to answer for the stream, by the way, quick overview is that Kyle actually says that layout tests are some of the fastest to write in practice because they follow a standard formula and they're pretty quick to knock out.
Can we use it for finding performance issues?
Question is, can you use it to find performance issues? That's a really good question. I haven't thought about that specifically.
I suppose you could just assert that it takes less than a certain amount of time to run.
Well, as it sits right now, the auto layout pass is kind of hidden within the library and implementation details. I suppose that data could be surfaced relatively easily. In general performance tests, I was really excited when Apple introduced their what is it? I forgot. Test performance of block or something. Yeah. That block API that they have. We haven't successfully really deployed anything for that, and like haven't really used them extensively. I've used them personally, kind of. I write these tests for my personal use when I'm trying to improve something, but I never actually end up committing the tests. This is so dependent on machine and architecture. We don't have any tests running on real devices, actually. And even if you do, I've talked to a few people who've managed to set this up, and it's like there's actually a wildly different performance metrics on one iPhone 6 to another iPhone 6, which I found quite surprising. So I think as of right now, it's not really set up for that. It's possible something we might want to add in the future. But other questions? Yes.
So you mentioned you guys are using your own version of KIF to drive the app.
Yes.
So does the framework depend on that specific version of KIF, or should we also be able to use it with XC UI test, for instance?
So the layout test, it doesn't depend on KIF at all. Our layout test and our automation tests are like very separate. These are committed as part of our unit test suite. We have different test suites for that. So yeah, it's completely separate from KIF.
Do you use different schemes for your builds for these tests?
Question is, do we use different schemes for these builds? For these tests, sorry. So no, not for layout tests. We have our like main app target, and if you run test on that target, it will run only our unit tests and layout tests. We have different schemes for like all of our different UI tests, so we have like 10 extra schemes for that. Yeah, go ahead.
So when you use that framework and you mentioned it makes HTML page with screenshots, right, of what went wrong, for example. Does it make it easier in your experience to communicate it back to the designer? Like, they kind of see it in isolation in this case, right? It's only that cell, for example, out of the context of the whole table and the screen. Is it helpful, or have you had any miscommunication because of that when you get it back to the design team?
Yes, the question is when we get failures and we look at the HTML screen, like how do we communicate this back to the designer? So I honestly don't really think that any of these tests ever get communicated back to design. I mean, I think that the designs that they give to us, they're always pretty. They always look good, right? So if we showed this to a designer, they'd be like, that's not what I gave you because that doesn't look pretty. Yeah, I think that mostly it's always that thing, right? If you find something, you find an edge case in the design and you're not sure how to handle it, my general opinion is like make a good call and like just like do what you think, and you know someone will notice later and fix something. Of course, you can go talk to design. Yeah, in terms of the actual catalog, we don't have that up and running actually for our app because it takes a bit more work to get that set up. So yeah, go for it.
Who writes your automated test and these layout tests? Is it developer or QA?
Yeah, question is who writes both the automated tests and layout tests. We don't have a QA team, so developers do everything.
Okay.
Yeah. So actually, as of right now, we run basically we run 0 manual tests. We like ship the app to the company and they give us feedback if they find bugs, and that's actually really useful. But we basically completely reliant on automated tests, layout tests, and unit tests, and they're all written by developers. Any other questions? All right. Cool.